Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at maths, exponents and surds, solving equations using the laws of exponents, past exam questions part 2. We continue with the November 2019 paper 1 and also the November 2018 paper 1. We're going to be picking questions which involve the solving of exponential equations and also solving equations with rational exponents. So let's have a look at a few questions from the 2019 examination paper. The first question I want to look at is question 2, and that is 2.2.1. So in question 2.2.1, we have solved for x. We're going to have to the x equals to 32. So if I can just basically have a look at it here. Remember that 1 over 2 is 2 to the minus 1. So you could say 2 to the minus 1 to the x equals 2, and 32 can be written as 2 to the 5, so that's 2 to the power 5. Now if you look here, it says minus 1 here raised to the power x. You can multiply the 2, which leaves me with 2 to the minus x equals to 2 to the power 5. And we've actually now achieved what we wanted to achieve, which is to have the same base on each side of the equal to sign, which means the bases fall away. Now you can equate the indices of exponents, so minus x equals to 5. Therefore, now you can conclude that x will equals to negative 5. And that's the answer for the first question that we're looking at, which is 2.2.1 done. The cube root of 1 over x squared equals to 4. That's the next question that I want to look at. So here we say the cube root of 1 over x squared equals to 4. So we're going to do the following, which is going to be cube root of x to the minus 2 equals to 2 squared. Now we're going to use this rule here, which is if I say the nth root of x to the power m is equal to x to the m divided by n. So therefore we'll have x to the minus 2 over 3 equals to 2 squared. Now if I look at this multiplicative inverse of minus 2 over 3, which will be minus 3 over 2, and even on this side to minus 3 over 2. See, if I multiply by this multiplicative inverse, I'll get x to the positive 1, which is what I want to achieve. So that will be x minus times minus is plus 2 over 3 times 3 over 2 is 1. 2 times minus 3 over 2 will be 2, and that's 2 times minus 3 is minus 6 over 2, which is minus 3. So as you can see now, we're going to be left with x equals to 1 over 2 cubed. 1 over 2 cubed is equal to 1 over 8. So therefore we can conclude that x is 1 over 8. Let's look at the next question. The next question that I want to look at is this one, 2.2.3. 2 to the x minus 12 over 2 to the x equals to minus 4. This is an exponential equation. But as you can see here, we got 2 to the x, which is being repeated in this particular equation. So I would now suggest that you use k-factor substitution, which is going to be as follows. You let 2 to the x equals to k. So you'll get k minus 12 over k equals to minus 4. And thereafter, we'll multiply across by k, and I'm sure we will get a quadratic equation. So we said that we're going to do the following. We're going to let k equals to 2 to the x. Therefore, we'll have k minus 12 over k equals to minus 4. Then we said that we're going to multiply across by k, which will leave us with k squared minus 12 equals to minus 4k. So we'll be left with k squared positive 4k minus 12 equals to 0. Now we have a quadratic equation which we are going to factorize by inspection. So k times k is k squared, and we're going to get 2 times 6 is 12. Factors of 12 multiplied together to give me minus 12 and added together to give me positive 4. That'll be positive 6 and minus 2. Check. K times k is k squared. Minus 2 times plus 6 is minus 12. Minus 2k plus 6k gives me plus 4k. Therefore, k equals to 2 or k equals to minus 6. Now, let's look at this. K equals to minus 6, so 2 to the x equals to minus 6. 2 to the x cannot equals to minus 6. So therefore here we'll write no solution. Why is 2 to the x not equal to minus 6? Well, if you look at the graph of 2 to the x, it will look like that. Y equals to 2 to the power x, and as you can see, there are no negative y values because the asymptote is equal to y equals to 0. Right? So therefore we can conclude that there's no solution there. So therefore 2 to the x equals to 2, x will equals to 1. That's my answer. So x equals to 1. Let's go look at the next question that I want to look at. So we've done everything here from the 2019 paper with regards to exponential equations. Let's look at the 2018 examination. Paper 1 and question 2 once again will be as follows. Here we got 2.1, which is 2 minus 16x to the minus 3 over 2 equals to 0. So let's see, let's solve this one over here. We'll say minus 16x to the minus 3 over 2 equals to minus 2. We'll have x to the minus 3 over 2 equals to. We divide both sides by negative 16. We will get minus over minus is plus 2 over 16 is 1 over 8, which leaves me with minus x to the minus 3 over 2 equals 2. Remember, 1 over 8 is 1 over 2 cubed. If I bring that to the top there, it's going to now become 2 to the minus 3. So therefore 1 over 8 is 1 over 2 cubed. And remember the rule now. It says that if I have 1 over x, it's equal to x to the minus 1. So 1 over 2 cubed is 2 to the minus 3. Once again, as you can see, learners, I want to multiply here by multiplicative inverse, or rather, in order for me to multiply by that multiplicative inverse, I must be able to raise to a power which is the multiplicative inverse of minus 3 over 2, which is minus 2 over 3. That's minus 2 over 3. Minus times minus is plus 3 over 2 times 2 over 3 is 1. So that's x. And here we'll have minus times minus is plus. We'll have 3 times 2 over 3, which will give us 6 over 3 is 2. So we've got 2 squared. So therefore x will equals to 4 there. So the next question that I'm going to be looking at is 2.2.2, which is 4 to the x plus 8 equals to 9 times 2 to the x. So once again, it's very similar to a question that we've just answered, but recognizing it is very, very important. So let's go ahead and look at that now. Now remember that 4 to the x is 2 squared to the x, which is going to equal 2 to the 2x. And when you've got 2x and then you've got 2 to the 2x and you've got 2 to the x, now that's a perfect example of, once again, of using k-factor substitution. So basically you'll have 2 to the x there all squared. So you can write it like that. So if you look at it carefully, you'll have k squared plus 8 equals to 9 times k, or 9k. Once again, we're going to get a quadratic. We're going to solve. So let's look at that 2.2. Do the following. I'm going to say 2 to the x all squared plus 8 equals to 9 times 2 to the x. So we're going to let 2 to the x equals to k. Therefore, we're going to get k squared plus 8 equals to 9k. K squared minus 9k plus 8 equals to 0. And if we factorize this now, because we've got a quadratic, we're factorizing by inspection. K squared is k times k factors of 8 when multiplied together to give me positive 8, when added together to give me minus 9 is minus 1 and minus 8. Check. K times k is k squared. Minus 1 times minus 8 is positive 8, and minus k and added to minus 8k is minus 9k. So k equals to 1 or k equals to 8. So therefore, what did we let equals to k? 2 is equals to 1. So therefore, it's going to be 2 to the 0. Therefore, x equals to 0. 2 to the x equals to 2 cubed. Therefore, x equals to 3. And there you go. That is our solution. Last question that I want to look at today is 2.2.3. The x root of 9 equals to 240. That the x root of 3 squared equals 2. Now let's try and get 343. with base 3. So that'll be 3 to the power 5 equals to 243. So that's 3 to the 5. So therefore, 3 to the 2 over x equals to 3 to the power 5. Bases are the same, bases fall away, so 2 over x equals to 5. You just have to equate the indices. Therefore, you'll get 5x equals to 2, x equals to 2 over 5, x equals to 2 over 5. And that's it, that's our solution. And as if you haven't subscribed already, subscribe to JL Maths. You can watch all videos in order of the work schedule on jlmaths.com. Also like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.